How's it going, man? You don't have to have your screen on if you don't want to. I know some people are real weird about that, but if I'm not going to use my video, you don't have to. We're just going to give it a couple more minutes. Some people are starting to trickle in here. Happy to have you guys along. I was a little worried that no one would want to show up, given that it's second week of the semester and the lab report isn't due yet. Generally speaking, I do prefer if you guys just speak up if you want to talk. If you have any questions, anything like that, please feel free to interrupt me as frequently as you feel like it. I don't like the chat feature, the text bubbles that pop up. They always go away too fast. I never see them, especially when I'm doing the screen share thing. So I much prefer if you just interrupt me. Also, sorry for not being clear about this being the meeting room that we would do everything in. I appreciate the email. How's the audio level? Everything good? You guys can hear me pretty well?
Yeah, I can hear you.
Yeah.
Oh, well, I couldn't hear either of you guys. That's interesting. What am I doing wrong here? Hmm. Just to confirm, could you guys hear each other?
Yes.
Okay, that's probably a yes. All right. Whoopsies. Glad I asked. It's a relatively new computer, so I probably just have the audio output going to something dumb like my monitor or something. Could somebody say something else, please?
Hello?
Hey, thank you so much, Dylan. Great to have you guys here with me. Jennifer, good to have you. We'll go ahead and get started now. I was just saying to them that I prefer if you speak up if you have any questions. Please feel free to interrupt me as frequently as you feel like it, and try not to put anything in the chat window that's supposed to go to me at least, because I tend not to check that, especially when I'm screen sharing. Um, all right, but let's get right into it. So, if you saw my announcement, which you probably did because you're here, you know that I care a lot about the lab reports. They are everybody's least favorite part about doing a lab. And unfortunately, you all have signed up for the online only section. Now, I know that you probably have your own reasons for wanting to do that. I think it's too bad that you're not able to be there in person, messing around with the stuff, feeling the heat of the Bunsen burner and pouring goo back and forth like chemists do. Um, but I do still want you guys to get something out of this class, and I think that the most important part of teaching a Chem 1 lab is learning scientific writing. Scientific writing is a very specific style. It's a style that's focused on getting as much information as possible into as few words as possible. It's very information dense, and it can be a really important skill. I think that, especially if you want a job in STEM, your employers are going to look at your resumes, your CVs, whatever you give them, any kind of work that you do, and they're going to want to see, all right, does this person know how to put a lot of information into very, very little text? Do they know how to have a logical flow to their writing? Is it all full of fluff? And most importantly of all, can you convince them of your assertion? Using facts and logic. And that's what we're going to learn in this class. We're going to be doing roughly two-page lab reports based off of a video that you're going to watch and some text that you read and worksheets and whatnot. And the idea is you're going to be doing something called argument-driven inquiry. I'm pretty sure that we had a little reading on argument-driven inquiry somewhere in here. Um, Let me see. We used to make you guys read that. Ah, here we go. So there was the video on argument-driven inquiry. Um, it's a very long-winded way of saying that you're trying to prove a point. So this is a type of persuasive writing in a way, but it's not persuasive like, oh, my way is the best. It's persuasive like, here are some facts, and now you can no longer argue that I am correct. You'll notice that all of our labs are kind of started with a question. For example, we're supposed to be doing the are these objects made of the same material for our first lab report. Um, when you go through and watch this video, you're going to see Professor Russell have several different objects in front of him, and he's going to do some measurements on those objects. The idea being that we're going to try and figure out by if they're the same material or not by using specific properties of those materials. Um, this writing workshop in particular is going to be focused towards getting you guys started writing your lab reports. It's not necessarily going to be an in-depth look at, oh, here's how you set up a good data table and here's exactly what your conclusion needs to have. We'll have other workshops later in the semester that'll get more into the nitty-gritty. I just want to show you where to find everything, and we'll go over a quick strategy for writing good introductions. So when you first come into the course, we have the calendar down here for you. I think this is a really easy way to find what you're supposed to be doing on a given week. For example, our lab this week would be technically best practices. Now, if you were doing it in person, you would be, actually in a lab setting, talking with the professor, with your classmates, and trying to figure out, oh, here's how a balance works, and here's how calipers work. You all are just supposed to be doing the pre-lab assignments and doing the readings. But for next week, you'll come down here, you'll see September 1st. It's a study of density, really, and then you'll click on the are these substances the same? And that'll take you to the correct module. Then you'll click on the pre-lab and do that if you haven't already, or you'll go ahead and watch the are these substances the same lab video. These have to open in a new window, so you'd click on that, and then you would see Professor Russell performing the lab for you. Okay. But this is really where you're going to find most of the most important information. This should have been in that same module linked. I'll correct that later. But this is going to be kind of the landing page for every lab we do. We have 4 big labs in this class. You'll see an introduction, which is kind of just trying to get you used to the basic idea, the chemistry concept that we're going to be exploring in that lab. You'll see materials for use. Now, of course, you're not going to be physically using those materials. You're going to be watching Professor Russell use them. Safety precautions. Again, it's pretty hard to hurt yourself watching a video, but you might choose to wear goggles anyway. And then the pre-lab. These are always supposed to be due the week before you actually perform the lab experiment. The idea of doing it in advance is that you're going to have a rough idea of what's going to happen in the video before you watch the video. A little bit like, reading the notes or the textbook before sitting through a lecture. It kind of gives you an idea of what's going to happen. So when the professor starts spouting some jargon, you're like, oh, okay, I know what that is. I'm okay. A lot of the times, if you try and watch the video the first time without doing the pre-lab, without doing the reading on this page, you're going to feel pretty lost, and you're going to either want to do multiple watches of the video, or you might just not get the information out of it. So definitely do the pre-lab first. I have the due dates set accordingly, but even if you miss doing the pre-lab, you're going to want to go back and do the ungraded version to make sure that you understand what's happening in the lab. A lot of the time, the math from the pre-lab, I'll expect you to do directly in your lab report. Okay. Here is the procedure. Now, a lot of you probably have had like a high school chemistry lab or bio lab, physics lab, something like that, where the professor asked you to put the procedure in. In my lab class, I expect the procedure to be included, but not this one, right? I don't want you guys to copy and paste this into your lab report. That's not helpful for me or for you. What I instead want is for you to paraphrase what you see done in the video. and to give insight about why those things were done in the video. What do I mean by insight? Well, for example, here we see okay, you're going to see when you watch the video that the professor uses at one point something called a spill can. Now, you're going to read all about that in the readings. You're going to see the professor using it in the video. I want you to maybe talk about why this part of the procedure is included. What benefit is there to using the spill can at that point? These are things that make the procedure more interesting because they tell me that you understand what's happening in the video, not just that you watched it and can regurgitate what happened. At all points throughout the lab report, I want you guys to be telling me that you understand what's happening. Show me that you understood the topic, you understand the chemistry. That's going to make it really, really easy for me to give you an A. Okay, let's see here. I think it's probably a good idea for us to talk about the rubric. All right. So when you click through here, you'll do the pre-lab, you'll watch the video, and then the next part, no, not that one. Sorry, that's for the in-person lab, and apparently the link is broken. Sorry about that. Glad we caught it a week early. That should lead to this page here at the end. Don't worry, I'll have that corrected. So our lab reports happen in two big parts. You're going to produce first a rough draft the same week that you do the lab activity. Because this is an asynchronous lab, it can be a little bit funny trying to figure out the timing on things. If you were doing it in person, you do the lab activity and then bring in your rough draft to the next lab meeting. But because you all are going to be doing the video and writing your rough drafts at any time you want during the week, I have to have the rough drafts due on the Friday that the lab is open to you. The reason we do a rough draft is because a lot of the time you're going to miss some key concepts. You might mess up the math. Your table might not be up to snuff. Maybe you didn't know how to do a graph in Excel, whatever it might be. This is an opportunity to catch yourself or to have your peers catch your work and then say, hey, actually, it should have been like this, or maybe you could improve by doing that. And so we have a formalized process that we call peer reviews, where you're going to submit a lab report. And then after the deadline passes, you will be assigned at random two other students' rough drafts, and two other students will be assigned your rough draft. The idea is that you're going to use this rubric that we see in front of us, and you're going to make some comments to say, I like what you did here, I didn't like what you did there, etc. The rubric that you'll use for the rough drafts is the exact same one that I use when I grade your final drafts. So it really helps to have this lab report rubric open when you're writing your report and make sure you're kind of hitting each of these ideas in the order that they are presented. Sure, some things, are going to be happening throughout, like organization and sentence fluency and word choice and conventions. I expect you to use proper words and conventions throughout your lab reports. But aside from those ideas, really, you can kind of just use this as a checklist when you're going through and writing your lab report. We start off by saying the author describes the concept under investigation, why it is useful or needed. And then the second one, the author clearly states the research question and relates it to the concept. I consider these first two criteria pretty much the introduction to your lab reports. And let's do just a quick demonstration of a writing style. I think is really, really helpful for when, how do I turn off AI bullshit? Can I make this go away? Okay, there we go. Awesome. Okay, so we're going to use something that I like to call the funnel approach to writing an introduction. Now, what is a funnel? A funnel is something that starts big at the top, and then it narrows down to a relatively fine point, and it allows stuff to flow in a very intentional direction. And that's kind of the idea that we want to get across with our introductions. We want to start from a big idea and then transition down to a specific idea, usually in about 3 to 4 sentences. Let me give you a good example by talking about something that I worked on in grad school. So my project was excited state intramolecular proton transfer as a novel method for sensing heavy metal ions. Do you guys care? Probably not. Because that was a lot of very specific jargon. It was very information dense. And you're probably asking yourselves, why should I care? Right? Or at least that's probably the general feeling is who gives a damn what this guy worked on? Well, to put it another way, it turns out that heavy metal poisoning is a problem that much of the country still faces, even in the year 2025. Lead and cadmium from both outdated piping and old paint on buildings frequently leaches into our water supplies and poisons young children. Uh, One of the most effective ways to detect metal ions in solution that could be harmful to us is by using fluorescent dyes. One of the problems with using fluorescent dyes is that they are non-selective for heavy metals and they often have the same wavelength of emission, and so you can't tell the difference between them. As a solution to this problem, we have developed excited state intramolecular proton transfer dyes, which will specifically fluoresce a different color based on the metal ion they are attached to. You see what I did there? I took it from the very general, everybody cares about this thing, right? Children getting sick, that's a bad thing. We narrowed it down and we said the problem that's making the children sick is the metal ions in the water. And we narrow it down again and we say, well, one of the reasons that this is such a problem still is because the dyes that we have to detect these things are not specific. And we narrow it down to the final step where oh, okay. So here is a specific new type of dye molecule that through this fancy process allows it to produce different colors of light depending on the metal it's attached to. And that's kind of what I want you to do in your introductions. So let's see if we can come up with one for this lab. Um, we're trying to figure out if substances are the same. Um, don't worry if it seems trivial. If it's like, well, of course, duh, we care about this. It's okay to write that stuff down anyway. All right. This is all practice. You're not necessarily reinventing chemistry when you're writing a Gen Chem 1 lab report. It's okay if you state the obvious. Um, Anybody feel like participating? Can somebody tell me why we might care if substances are the same or not?
I'm honestly not sure. Sorry.
No, that's fine. Let's talk through it. Well, first of all, what is a substance? No wrong answers here.
Something that has mass and volume.
Yeah, pretty much. And it turns out everything has mass and volume. And if it doesn't have mass and volume, then it's just energy, right? And I don't really think of energy as a thing, but maybe that's because I'm a chemist, not a physicist. Anyway, I digress. Yeah, so stuff, right? The matter or the universe is made of matter. And if, let's say, you took some yellow metal into a pawn shop and you said, give me all your money. I have some shiny yellow metal. Are they just going to give it to you no matter what? No, of course not. They want to make sure that the stuff you're bringing in is the exact stuff that they think it is, right? There are a lot of different scenarios in which we would care, is this thing the thing that we think it is? Um, so let's start real broad here. The universe is made of matter, and much of that matter looks the same. Would you guys agree? Put a comma where I paused,
Yes.
but yeah.
Yes.
Yeah, definitely. For example, metals, right? Sure, I listed gold as an example, but that's probably a bad example because gold's the only yellow one, right? Um, Most other metals look identical to each other, right? They are shiny, they are cold to the touch, they turn kind of red and glowy hot if you heat them up. Um, so differentiating between similar looking substances is an essential part of life, industry, etc. Let's see here. Between different substances is a necessary task, skill. It's up to you guys. Task slash skill for industry, life, health, safety, etc., etc. Okay, let's narrow it down a little bit more. Did anybody read over this lab that we're going to be doing?
Yes.
Okay, so we're going to take what? We have three different objects, right?
Yeah.
Yeah. Um, so then you might draw it into this particular lab. So in this week's lab, we were tasked with identifying which of three different objects uh, were the same slash different. Could probably find a slightly better way to say that, but we're just making it up as we go along here. And what's the property that we're going to explore to see if they are the same slash different?
Their density?
Yeah, density, that's right. Um, so we might talk about density then, maybe even before this part. That would make more sense to me. Um, when substances are made of the exact same stuff, they must have the same density. Density, as it turns out, is an intrinsic property of matter. If something is, like, let's say, a particular element, like silver, let's say, then all silver must have the exact same density. Or if you had polypropylene plastic, all polypropylene has the exact same density. And so by analyzing an object's density, we can determine if it's made of the same stuff or not. And so let's find a way to say that. When substances are made of the exact same stuff, they must have the same density. By comparing objects' densities, we can rule out whether, or we can, let's say we'll just determine, we can determine if they are made of the same stuff, if they have the exact same density. In this week's lab, we were tasked with identifying which of three objects were the same or different. And then I know this lab a little bit better than you guys, so I'm just going to say by measuring their volumes by two different methods and their masses, we can calculate their densities to determine if they could be identical substances. You see how we went from a very big idea and we kind of narrowed it down and narrowed it down and we funneled into the actual purpose of the lab. I think that's a really, really convenient way to kind of start an introduction, especially when the concept is as nebulous as are these the same thing? It just helps to guide your writing a little bit, and I think that you'll probably find it's quicker and more effective as a strategy. Do I have any questions at this point?
Yes, I do have one. Is there a specific type of format you want us to write our lab reports in, like font wise and everything else?
Font, please don't get creative. Anything that is what I would call standard.
Okay.
So, some people go through the effort of switching to Times New Roman. I think that Arial works fine. That's what most word processors default to. I think that in terms of not giving you guys too much extra writing to do, probably 12-point font and double spaced. And I
Okay.
apologize if that isn't written anywhere. I borrowed this from a different colleague, the lab outline here.
Mhm.
Um, so I'll make sure I put those detailed directions somewhere that everybody can find them. Thanks for pointing that out. Yeah, 12-point font, double spaced. And if you're doing the 12-point and double spaced, please don't use a bunch of white space when you're writing. Um, I've seen students they'll like put a table in and then like they have like half the page left and
Mm,
they like skip to the next page because there was a table there. Definitely try and fill the page.
gotcha.
Um, I'll-
Thank
I,
you.
yeah, of course. Any other questions?
So no like APA format.
Oh, no, no, no. You don't have to cite any references in this class. All of the information that you need is contained within the Canvas shell. Of course, I will be thrilled if you go out on the internet and figure out, like, oh, okay, so here's a reference and it has useful information, and I'm going to put that in here. You can totally do that, but I don't expect you to cite sources. Um, if you meant APA format, like just like the writing style, that's fine too. Um, whatever makes you happy. Much more interested in
Thank
the
you.
substance than the style. Good
Thank
questions.
you.
Yeah, of course. Anything else, guys? Okay. Well, in the interest of not droning on for quite so long, I think we are going to wrap it up there. This was a good introduction. I hope that you all saw how to get everywhere. Again, some of the links were broken, but I'll have those fixed up. Um, and next week, we'll be submitting our rough drafts. And I'll probably do another one of these videos then to show you how the peer reviews are supposed to work. They should just pop up in your to-do list or whatever, and you just click on the student's report, and then you'll have this rubric there. But I'll make a specific video about that when the time comes. Thank you so much, you three, for attending. I really appreciate it, and I hope that you got something useful out of it.
Thank you so much. Have a good one.
Yeah, you
Thank you.
too. Yeah, of course.
Thank
Take
Thank
you.
care.
you.